All right, why don't we get started? Welcome, everybody. Welcome to the very first ever online workshop from the North American Maple Syrup Council, and sponsored this evening by CDL. Thank you to their contributions to making tonight happen. This is the first of what we hope will be a number of these. We're always looking for new ways. The council is always looking for new ways to get information out to sugar makers, to forward our mission of helping you all make the best syrup possible. And quite honestly, there's no better way to do that than starting out with Dr. Abby Vandenberg from the Proctor Maple Research Center at the University of Vermont. Many of you have heard Abby speak at your state or provincial association's annual meetings or at the annual council IMSI meetings. And Abby's been working on tips and tricks around maximizing yields, and she is going to help us all be better sugar makers tonight. I am recording this, so it will be available online, so you can sit back and enjoy your beer and not have to take notes all evening. Do think about questions, though. Feel free to use the chat function for your questions. I'm going to keep everybody on mute for now. And we'll have some time at the end for Abby to answer some of your questions. So with that, I'm going to turn it over to Abby.
All right, thank you, Winton. Thank you for that really lovely introduction. So welcome, everyone. Thanks for being here, sharing your evening with us, and just adjust some things here. So as Winton said, this presentation is going to be a fairly wide-ranging one on some keys to maximizing yields. And you can see that I have in parentheses there, optimizing yields. And I'll explain as I go along why I really prefer the word optimize rather than maximize. And I'll explain what I mean as we go on. And I know that there are a range of people here at this talk. So there are people here that have probably been making maple syrup for 30 years or more. Probably some brand new producers, people with thousands of taps and all the latest technology, or a few taps on buckets. And hopefully the way the presentation goes, that I will cover something that is new to each and every one of you, no matter what your experience level is, something that you can use and take back to your operation, or maybe a new way to think about something. So here we go. So I'd like to start this presentation with this figure, and it is the long-term average yield at the UVM Proctor Maple Research Center, our actual demonstration sugar bush there. And I use it to highlight two main points, and now that we've had 2021, it highlights the second point even better than ever. But the first main point that sets the stage for this presentation and this seminar is that you can see that the long-term average at the Proctor Center is just at 0.6 gallons of syrup per tap. And so the point that I'm trying to make and illustrate here is that despite the differences in the season that we have, using best practices and tools, different tools and techniques, we've been able to consistently maintain a relatively high yield per tap over time, despite what Mother Nature gives us from year to year. However, and so those are going to be the things that I talk about today, some of the major things that we implement to help us achieve that relatively high long-term average. It's higher than the Vermont average, and it's quite a bit higher than the US average. But what the second point that this figure is there to illustrate is that Mother Nature ultimately controls everything. So no matter how hard we work and how much great technology we have and how careful we are, what techniques that we use, no matter what, ultimately what we are able to achieve at the sugar house and what we're able to get from trees depends on what Mother Nature gives us. The weather conditions, the amount of freeze-thaw cycles, the sap sugar content in the tree depends on weather and lots of environmental variables. So this is highlighted. You know, the poster child for that used to be 2012, and now it is far and away 2021, the year in which really Mother Nature gave us a series of challenges and a series of factors that even the best possible techniques were not able to truly overcome. However, there were many techniques that could be used that did help many producers do better than others in a challenging year like this, and we're going to talk about some of them today. So, with the understanding that Mother Nature really controls all and is the ultimate decider, there are, after that, really 3 major factors that affect the yields that we're able to get from trees, so the amount of sap that we're able to extract from individual trees. The first one is obviously the level of vacuum. We also have sanitation practices, tadpole and tubing sanitation practices, and then a whole category of factors related to our tapping practices, as well as factors related to the tree, everything from tree size to growth rate to the number of taps per tree. So what I'm going to do essentially in this presentation is go through some of the major practices in each of these categories that help us achieve the sort of optimize each of these factors. Certainly it's not going to cover everyone. We would be here until probably 2022 if we were going to do that, but we'll just hit the main points or some of the main points. And then after that, talk about some factors beyond these factors, beyond the level of maximizing the amount of sap we're getting from trees, and talk about some of the other factors that can reduce our yields on the other end that are very preventable and that we have a lot of control over. Okay, so first and foremost, we start with the level of vacuum, and certainly really vacuum, the level of vacuum above all is the single biggest factor that affects the yields that we're able to achieve from trees. So research that we've done, which is illustrated here, as well as research by Center Acer and other groups, have shown consistently that there is a linear relationship between the level of vacuum and the amount of sap that we're able to extract from trees. And so we see in all of those studies about essentially the same relationship. We see between a 5 to 7% increase in yield with each inch of mercury vacuum that's lower or higher, depending on how you want to look at it or how you want to express it. So, and this continues, this study here only looked to 24 inches, but this continues up to 28 inches. And so this is kind of a no-brainer. We all essentially know this, but the key is, of course, it's not the level of vacuum at the pump. If that were the case, then this would all be easy and I wouldn't even have to give a seminar. But obviously the level that matters is the level of vacuum at the tadpole. And so when it comes to maximizing vacuum or using vacuum to maximize yield, it's all about techniques and practices to help us maximize the level of vacuum at the tadpole, or really minimize the difference between what we're getting at the pump and what we're getting at the actual tree itself. So first and foremost, the single biggest factor to help maximize the level of vacuum at the tadpole begins with the design and installation of the collection system. Obviously, it's a huge topic, and so I'm just going to touch on a couple of things. But before, basically for any collection system in design, I would suggest everyone go and read and refer to the New York State Maple Tubing and Vacuum System Notebook. This is an amazing resource. It is highly technical, very detailed, and gives you tons of information and background information on what is a well-designed tubing system and why that is a well-designed tubing system. So even if you're going to go have a professional design and install your tubing system, it's a great idea even still to take a look at this so that you can have a better idea of what are the good questions to ask and what should you be looking for. It'll really help you save money, save time, and also maximize your vacuum level in the end. And so obviously some of the big things are you need to have a good layout for your specific site, which is very variable per site. But one of the biggest things that we often see overlooked or maybe not quite as much care taken is having appropriately sized main lines. This is something that can sometimes be pushed away because, oh, I've got this leftover 1-inch main line and I'll use it, things like that. But really, maximizing the level of vacuum at the Tadpole begins with appropriately sized main lines. And the reason for that is because there needs to be enough room in that tubing to move both the sap and the air. Vacuum is extracting the air molecules from the tubing. So both of those things need to be able to move. If there is too much liquid in the pipe, there's not enough room for the air to be evacuated, and vacuum levels will drop fairly significantly. On the other hand, if we have pipes that are oversized, we can have a condition where there's not too much liquid in the pipe, and that in certain conditions can really promote a decrease in syrup quality because of sap heating when it kind of sits in the pipe. So it sits in the main line. So there is such a thing as a main line that can be too big for a particular situation. Essentially, we want to aim for, well, the opinions vary, but we want to aim for main lines that are no more than half full at peak sap flows. Some people say a third, but we want to make sure that we have plenty of room for that air and the sap to move. And this is going to, in considering what maximum flow rates are going to be, another thing that tends to, or let's say can be overlooked, obviously we're planning for the number of taps, but we do have to factor in the level of vacuum that we're going to achieve in terms of, the kinds of yields that we're going to get. And we also need to factor in what is the predominant species. So, and we'll talk about this later potentially, but, overall yields from sugar maples and red maples are at the end in terms of syrup about the same, or if not the same, but red maples tend to produce much more liquid, much more sap with a lower sugar content. And so if we have a bunch of red maple, we need to consider that when we're designing and sizing our main lines because we need to make them bigger in order to accommodate those higher levels of liquid. So next big thing in terms of the installation of the collection system is, and I put this in case there are, or in particular for people that have operations on really flat sites, it is extremely important to maintain a minimum slope with no sags, even when the main lines are completely full, all the way to the collection point. So this is something, this is one picture of pictures that I could have 1,000 of, where everything is nice and straight and downhill all the way until it comes into the sugar house. Things like this can have a big impact. This is where sap will sit, it will freeze, that will not defrost as fast as the rest of the system and reduce yields, things like that. It can also, sags in our mainline systems can also provide a place for sap to get kind of gnarly and lead to reductions in sap quality. So even on flat land, maintaining that minimum slope is super important. And when you do that, if you are in a flat place, it is extremely important to recheck the slope. So if you're working right on the cusp of completely flat main lines, it is very important to recheck, especially after the season has started. Once we start to have freeze-thaw cycles, a lot of times there can be enough shift in the ground to actually reverse or at least eliminate that slope. So you can have this like nice, very tight system where everything is maintained at just a perfect amount of minimum slope. And then as soon as you have a couple of freeze-thaw cycles in the spring, it all goes cattywampus and there's no more slope and you've got freezing and your sap isn't coming in and you don't know why. So it's really important to do that. And maintaining that minimum slope without sags really requires as much support as is needed, often more than you think. This is a really great example of a main line with totally enough support, or at least it should be enough support to be fully full and maintain its slope all the way down. Another aspect of the design of the collection system is the number of taps per lateral. So we've had a lot of research from us and actually other groups too that show that the increase in the number of taps per lateral line reduces yield. So the larger the number of taps per lateral line, the lower the yields go. So really the sort of rule of thumb of, strive for 5, and now I think we're hearing more like aim for 4. Those are probably good rules of thumb to work with. Going a little higher than that is not going to be the end of the world. Going too much lower than that can technically be beneficial in terms of actual vacuum to the level, to the tap hole, but at an increased cost. So it's something that needs to be balanced, and that's why we sort of say aim for the 5 is a good target to aim for. And then obviously, once you have a nice, perfectly designed collection system, maintaining the tightness of that system and how we maintain and manage it is really important. And obviously, the tightness of that system is key. So in any vacuum system, no matter how we accomplish it, we need to make sure that there's a rigorous system or a rigorous plan for leak checking and repair. To make sure that there are no leaks and the maximum level of vacuum is maintained at all times. Monitoring systems can really help with this. They can help you troubleshoot where big problems are without having to do a full tour around the woods. They often don't prevent you from having to do a full tour around the woods, especially for finding really tiny leaks. But in terms of really knowing how to deploy or how to best deploy your limited resources, especially if you have labor issues, they can be great for that. Another thing that I hear a lot and talk about a lot, and especially from producers in areas and have sugar bushes that are off the grid, don't have a good source of power, when this is with respect to how to operate pumps. Essentially, based on the research that we've done and our experience in our own sugar bush, it is optimum to maintain the pump on as long as the sap is flowing, essentially not turning it off until and unless everything is completely frozen and frozen for a long time. Essentially at the Proctor Center, we turn the pumps on at the beginning of the season and we never turn them off. Maybe if there is a period of 2 weeks of very, very, very cold weather, we may turn them off. But essentially it is optimum to leave them running all the time to make sure that there's no backflow, to make sure that that system is maintained under vacuum at all times. A variable frequency drive can help ameliorate the energy usage of doing this. So basically that throttles down the motor to use less power when less is needed. So it's a really good way to kind of be able to set it and forget it. And so that's just another factor to optimize the management of that collecting system. There's a great video. We have a series of videos on the Proctor Center's YouTube page with some very helpful tips and techniques for maintaining high yields or maximizing yields. One of them is on detecting and repairing leaks, which I think is a great one, especially if you're new to maple production. It gives you some great hands-on examples and picture examples, video examples of how to best do this, and is a good starting place, especially if you're new to maple production. And so the last thing that we want to do in terms of maximizing vacuum at the tap hole is to select the pump. Obviously, it's tempting to start from here. You want to start with the biggest pump to get the lowest level or the highest level of vacuum that you possibly can. So the biggest pump that money can buy. And ultimately, superficially, that is what pump selection is. You want to get enough CFM and power to be able to move air and overcome the leaks in your system, whatever size and types of system you have, at the desired level of vacuum. And so there are rules of thumbs about this, 1 to 1.5 CFM per 100 taps. That's the math part. That's simple. Really, the difficult decisions, the things to really think about when you're considering what pump am I going to buy, is definitely not, oh, I want the maximum amount of CFM and the biggest pump and the lowest or highest level of vacuum possible. Really, the optimum size and type for you is what works best for you in your situation. Because all of the pumps that we have in maple reduction, each of them has their own special needs, their special sensitivities, whether it's they are very intolerant to freezing, they require rigorous maintenance during the season, whether they're very sensitive to having sap get into them. All of these things are things you need to be aware of when you're buying a pump to make sure that you're willing to deal with that special need and that special sensitivity and to mitigate for that particular need of that pump. And then other questions that are also super important is, how close is someone to repair this pump? Am I going to have to wait a week for someone to come from 3 states away to repair this pump if it goes down in the middle of the season? Do I need to have 2 spare pumps to compensate for it because of that? How hard is it to get parts for this pump? How much maintenance? Those are all questions that to me are very important when selecting a pump. And then another thing to consider as you're sitting there dreaming about the highest level of vacuum you could possibly achieve in the most expensive pump is that as we reach higher vacuum levels, so when we get up to 27, 28 inches of vacuum, at those levels of vacuum, things that weren't leaky at 21 and 23 inches of vacuum all of a sudden become very leaky. And so we get a lot more micro leaks in situations where we have higher levels of vacuum. When we have those micro leaks, remember that again, at higher levels of vacuum, the temperature or the freezing temperature actually is raised. And so sap is going to freeze at a higher temperature. So at 28 inches of vacuum, it's going to freeze at around 39 degrees. And that means that if we have leaks, we'll have more freezing. And those where we have freezing, it's going to thaw out way later than you expect it to, and then that the rest of your trees are actually defrosting. So when we have higher levels of vacuum, it really increases the amount of labor we have to devote to rigorous repairing and detecting leaks, and really in the installation of the system to be as leak-free as possible. So having higher levels of vacuum can actually be a little bit of a trap and get us into a situation where we're doing a lot more work than we thought we were going to. So it's just something to be aware of. Okay, and releasers are sort of like pumps in that there's not a one-size-fits-all releaser for everyone. Clearly, with electric releasers, we have less backflow. So this is going to be better for yield ultimately, as we'll talk about when we talk about sanitation. But of course, they require power, so they need to have you need to have something to mitigate what's going to happen, and what are you going to do if there is no power? Because that's something that might happen in a sugar bush somewhere, that you might lose power. Has that ever happened to you? And also, some of the pumps in certain electric releasers can be challenged both at higher flow rates and at very good levels of vacuum. So it's important to shop carefully for the releaser, for an electric releaser, if you buy it, to make sure that it is sized and appropriate for the levels of vacuum and the flow rates that you expect to achieve. Okay, so that is, we could talk for 3 days about vacuum, but those are kind of some of the high notes. So next, the category is a broad range of things under tapping practices and factors related to the tree. So some of these are no-brainers, but although they're things that we intuitively know the relationship of, they're things that help us, that help to have numbers on them in order for us to make better decisions. So first and foremost, in terms of tapping practices affecting yield, we know that tapping depth is one of the factors that has the biggest effect on yield. So We did a study for 3 years at the Proctor Center from 2018 to 2020, where we looked at the yields from various tadpole depths. And this figure is presenting the average of those studies over the 3 years. And they're presented as a percentage of a 1.5-inch deep tadpole. So essentially, if we set the yields from a 1.5-inch deep tadpole in the study to 100%, how do the yields of the other depths relate? And so you can see, first of all, that the shallower tadpole, so going to a 1-inch tadpole, resulted in significantly less sap than a 1.5-inch tadpole, so about 60% less. So clearly a pretty significant reduction in yield by reducing from 1.5-inch to 1 inch. But then things kind of get interesting as we go a little further, go a little deeper. So once we get above 1.5 inches, you can see that there really isn't much difference at all between 1 3/4 all the way up to 2.5. So really, based on the results of this study, going any deeper than 2 inches is really not necessary. There's really not much benefit from creating a bigger hole and more non-conductive wood in order to go deeper than 2 inches. So, you know, like I said, this is a relationship that we intuitively know. Deeper tadpoles usually yield more sap, but being able to put some numbers on it and actually see that going deeper than 2 inches generally doesn't result in more sap helps us make better and ultimately more sustainable decisions. Another tapping practice that obviously impacts yields is spout diameter. And this is something that studies that we have done, as well as studies at Center ACER has done, have shown approximately the same relationship. So we see essentially a linear relationship between spout diameter and yield. And we see, for example, and this is something that people often are considering, you know, which should I choose, 5/16 inch or 1/4 inch, we see about a 10% reduction going from 5/16 inch to 1/4 inch. So it is a potentially small reduction, but that 10% can be a significant reduction depending on your situation. So as we'll talk about a little later on, that 10% is something that we can balance when we're looking at things as a whole in terms of what's going to be sustainable and give us the optimum yield over the long term. And then, of course, the number of taps per tree impact yield. But there are some surprising results with respect to this, at least in our recent studies. For 2 years, we looked at the yields from 1 or 2 taps, and this was in a study using red maples only, which will come to importance later. But what we saw in 2019, our trees with 2 taps had about 10 gallons of sap more than our trees with 1 tap. So a slight gain, but certainly not double or anything like that. And so that's relatively what we expected. But then in 2020, we saw that there was no difference in yields between our trees with 1 tap and our trees with 2 taps. And what we believe that we were seeing here is essentially that with higher levels of vacuum, vacuum is able to propagate within trees. And so at our higher levels of vacuum, the sap from 1 tadpole is basically able to cannibalize the sap from the other tadpole. And so we see diminishing returns with adding additional taps when we have higher levels of vacuum. And that's obviously going to increase, or those diminishing returns will increase the smaller the size of the tree. So if we're tapping trees with 2 taps that are right around the diameter where we might consider adding 2 taps, like around 18 inches, that's going to have less of a potential benefit than if it was a much larger tree with much more area to pull from. Okay, so obviously we know that deeper and larger tadpoles, more taps per tree, are generally going to result in higher yield. But the balance of that is that we also know, of course, that this is going to generate more non-conductive wood. And so the first question is, how much more non-conductive wood? And I don't have a great answer for that. I can tell you that in general, that the volume of non-conductive wood is generally proportional to the volume of the tap hole. So generally speaking, bigger holes mean bigger non-conductive wood columns. So if we've got deeper, wider, more taps per tree, we're going to have proportionally more non-conductive wood. So our tapping practices impact how much non-conductive wood we add to the tree each year. And generally speaking, on average, at least in studies that I've done in the past, we saw about that there were about 50 times, or sorry, the size of the column of non-conductive wood was about 50 times the volume of the hole on average. However, it's highly variable. In that study, the average was 50, but the minimum was 14 times the size of the hole, and the maximum was 200 times the size of the hole. So really a big range. And this is something I like to show because I look at these things all the time, but not everyone looks at these. So I think it's helpful and interesting to look at some of these cookies sometimes. This is a set of cookies that I starting cutting through the center of the tap hole and working in 2-inch cookies upward from the tap hole. So this is 2 inches above, 4 inches above, 2 inches below, 4 inches below. And this is like the poster child of a nice tree. We see that there's no more non-conductive wood about 4 inches above and below the tap hole. So this is a super great compartmentalizing tree, and it's just what we want to see. However, it is fairly rare in my experience to see this minimal amount of non-conductive wood. More common is something like this, where we see this is the center of the tap hole here and going up in 2-inch increments till we can't see it. Actually, we're still seeing it here. And then here is going down from the tap hole, and we're seeing that non-conductive wood continue. This is 14 inches below, this is 12. I ran out of room to put the cookies on the page. And so this is much more common for what we see, 12 inches, 14 inches, 16 inches above and below the tap hole. And those are conditions where the tap hole has not intercepted any pre-existing non-conductive wood. When that happens, so when we have a situation like this, where the non-conductive wood from this tap hole intercepted and interacted with some pre-existing non-conductive wood that was already in the center of the tree, when that happens, typically the amount of non-conductive wood that's generated in response to the new tap hole is explosive. And you can see that here. This is this set of cookies. You can see that, 4 inches above, that stain is really not any smaller than it was to begin with. And the same for below is just perpetuating. And these cookies, the stain went on for 24, 28 inches, something like that. It can be an incredible amount more. So it's something to think about. And this I put in there, you can tell I like to look at these. This I put in there to show that you can see this is from a tap hole. So you can kind of see the tap hole only went about this deep, but it interacted with non-conductive wood that was in the center of the tree, even though it was really far away. So that kind of weirdness can happen. You can see it's happening all over this particular tree. Yeah, just to highlight the point that the tapping practices that we use impact how much non-conductive wood that we're adding, but there are also things that go on in the tree that we have no control over and sometimes no knowledge of that are going to impact the level of non-conductive wood developed as well. Okay, so the tapping practices that we use also impact the chances of hitting non-conductive wood each year when we tap. And this comes to be basically, if we start by looking at the tapping zone of a tree, and I'm using a tubing system, we can think of the tapping zone in a gravity system too, but for now, we'll just think of it in the tubing system. The tapping zone is basically the area that's accessible with the drop line. So everything that's accessible with this drop line. So if we take the tapping zone and basically unfold it from the tree, we can see that the tapping zone is actually just a 3-dimensional rectangle. And it's defined in 3 dimensions in 2 of the 3 dimensions by factors that we control with our tapping practices. So obviously, one dimension of that tapping zone is defined by how big the tree is around, so the tree circumference. But the height of the tapping zone is defined by the drop line length, which is something we choose. And the depth of the tapping zone is defined by our tapping depth, which again is something that we choose. And so the tree, not just the tree size, but also our tapping practices determine the total volume of the tapping zone. And that is the maximum amount of potential conductive wood we have available to start within the tapping zone for us to tap into and collect sap from. And then we also, as we just went over, our tapping practices determine how much non-conductive wood is added to the tree annually. So this determines how much non-conductive wood is added to that tapping zone. And then if we put those things together, what we can see is that the proportion of the tapping zone that is non-conductive wood is actually equivalent to the chances of hitting non-conductive wood when we're tapping. So for example, if 20% of the tapping zone is non-conductive wood, we have a 20% chance of hitting that non-conductive wood. And vice versa, if we have 80% chance of, 80% of the tapping zone is non-conductive wood, we have an 80% chance of hitting non-conductive wood. So as non-conductive wood accumulates in the tapping zone, the chances of hitting it increase. And this is one of the reasons why not only are our tapping practices important, but it's really critically important to understand and know what the tapping history is of our trees, to know just how much of the tapping zone of that tree is comprised of non-conductive and conductive wood before we even start. And then putting this all together, the tree growth rates, another tree factor, is going to impact both the amount and the chances of hitting non-conductive wood annually. This is because it's tree diameter growth that determines how much new conductive wood is added to the outside of the tree each year. And also, when the tree is adding that conductive wood, some of the existing non-conductive wood is actually removed from the tapping zone, because remember, the tapping zone is only as deep as our tapping depth. So as we're adding new conductive wood to the outside of the tree, some of that non-conductive wood toward the inside is now deeper than our tapping depth and is no longer there. So vigorous tree growth is actually the factor that underlies everything and determines how much non-conductive wood is present, how much conductive wood is present, and thus the chances of tapping into either one. And this is of course critical because tapping into non-conductive wood impacts yield. And again, this is another one of those things where you don't need a scientific study to tell you this. You all know and have experienced tapping into punky or brown wood or an old tadpole. That results in little to no sap, or less sap maybe is what you've observed. But putting some data on that allows us to see just how significant the reduction is. And a study that my colleague Mark Iselhart from UVM Maple Extension, he did, where he intentionally tapped into old tadpoles into non-conductive wood and quantified the amount of sap extracted compared to tadpoles that were tapped into conductive wood in the same trees. And what he saw was that the average amount of sap from tadpoles drilled into non-conductive wood was 75% less than tadpoles drilled into conductive wood. So not just a little bit less, but significantly less. And so all of these factors that interact to determine how frequently and what our chances of tapping into non-conductive wood is or are, those are critically important because ultimately they're going to come back to hit us and impact our yields significantly. And so when we talk about tapping practices in particular to maximize yield, what we really mean is that we want to maximize yields for the long term. So our tapping practices need to balance the current yield that we're able to obtain with the amount of non-conductive wood that's going to accumulate from those tapping practices as a function of how well the tree is growing, what its size is, how much non-conductive wood is already there, because ultimately that's going to determine future yields. As non-conductive wood accumulates, our chances of hitting it and reduce yield increase. And that's why we tend to like to express this as optimizing yields rather than maximizing yields, because we need to optimize them not just for today, but over the long term. So I think I'll skip this one for today. Another factor that's related to the tree and yield is actually just tree size. And again, like most other things that I'm talking about tonight, this is also a no-brainer. We all have some intuitive sense and some experience that yield generally increases with bigger trees. Our studies have shown that roughly, using vacuum and very good sanitation, roughly we see about a ½ pound per inch increase in syrup production, per a ½ pound of syrup per inch of tree diameter, up to larger sizes where we're going to be adding 2 taps. But we see lots of variation in this, just like we see lots of variation in yields from tree to tree. But there are other things. So not only are small trees, the yields aren't so big, we have some other things that play into making tapping small trees even less of a good idea, I should say. Well, here's another set of data from a study where we were just looking at what are the yields from kind of tiny trees. And so on first look, you could say, well, wow, a 4 or 5 inch tree could get me 1/10 of a gallon of syrup per tap. And that's nothing, that's not nothing. But then you have to think about what we're doing when we're actually tapping, sort of put the big picture and the long-term picture into the frame when we're thinking about maybe thinning with a tapping bit instead of thinning with a chainsaw. So those small trees, those 4, 5, 7 inch trees, not only are they yielding fairly substantially low amounts of sap, but because of their small size, the relative percent of non-conductive wood in the tapping zone increases with decreasing tree size. So small trees have much smaller tapping zones, but you put a hole of the same size in that tree, it's going to make the same amount of non-conductive wood as in a tree of a bigger size. And that takes up a much larger percentage of that tapping zone than it does in a tree of standard tapping size. So non-conductive wood accumulates much faster in smaller trees, and our chances of tapping into it increase much more rapidly. And many of these smaller trees are often subdominant in the canopy, so they're not the main canopy trees like our main crop trees. These trees that are lower in the canopy have much slower growth rates relative to their dominant or co-dominant neighbors. So that makes even worse an already rapid non-conductive wood accumulation, because slower growth rates mean that new conductive wood is being added even more slowly. So you can see where tapping small trees just kind of perpetuates itself and has multiple factors contributing to making it sort of a very not attractive idea after a year or two. So in terms of putting these factors together in the long term to optimize yields over the long term, the first thing to do is to know something about the growth rates and the amount of non-conductive wood in your trees. So one great thing to do is to get an idea of how well your trees are growing is simply to monitor the diameter on a marked location on some trees in your sugar bush, or you could even get fancy and establish some permanent plots. But by doing this, basically measuring in a marked location over time of a subset of trees, you can get a fairly good idea after a couple of years of how well those trees are growing. You can also, of course, get very fancy and have someone come in and measure them with increment cores like these here. But in most cases, this is not fully necessary unless you need to have an immediate idea of exactly what the growth rate is today. And then another very, very important practice to do is to estimate how frequently you are hitting brown wood when you're tapping. So are you hitting brown wood in 5 out of every 10 tap holes, 9 out of every 10 tap holes? How frequently are you doing it? And that is going to tell you a lot about whether your tapping practices need to be adjusted in order to maximize the yield that you're able to get both in this year and in the future, as well as to maximize the sustainability of over the long term. And so also, before doing anything to tapping practices, in order to optimize yields over the long term, the first thing you're going to want to do is do anything you can to promote the growth and health of your trees. And that really means, in most cases, I want to say almost all, or maybe all, but at least most, that over time you are going to need to be doing some thinning and other forest management to promote the growth of your crop trees. So thinning with an actual chainsaw and not a tapping bit. Sure, you can do it with a tapping bit. It's not going to kill a tree. You will eventually need to come and cut that tree out with a chainsaw to give your crop trees space and light to grow. The longer those trees that need to be culled are sort of there and in the way, yes, you might be getting a modest amount of sap from them, but you will be basically hampering the growth and the rapid growth and health of the trees that you're really getting most of your sap yields from. So, and in some places, promoting growth and health may require or be helpful to have liming or other soil amendments, but this is really only where it's needed. And then other best practices to take care of your trees, things like good roads, taking care of your roads and soils, taking care of your crop trees when you're doing that thinning or doing any other work. It's really important to maintain the whole health of your forest, to maintain the growth and health of your trees. And there's a lot that goes into that. So once you have all of your practices in place to promote the growth and health of your trees, then to optimize yield, you're really going to just want to choose and adjust the tapping practices to balance the accumulation of non-conductive wood and yields that you would like to have with the growth rate and existing non-conductive wood of your trees. And so basically, first, you're going to focus on practices that don't impact current year yield. So if you need to adjust tapping practices to be a little bit more sustainable and to not hit non-conductive wood too much, the first thing that we can do is adjust the size of the tapping zone. We already know that a larger tapping zone is going to equal more non-conductive wood. So simply by increasing the drop line length, we can have a substantially larger volume of conductive wood to work with without having impacted any of our current year yields. We can also do this a little bit by moving the lateral line system vertically, or moving buckets vertically for those on buckets or bags. You can get a lot out of this, especially by basically using variations in annual snowfall to our advantage. And then the third way that we can do this is by tapping below the lateral line. This exploits basically double the area of our standard tapping zone by tapping below the lateral line. And our studies, as well as others, have shown pretty solidly that when you're using best practices, so high levels of vacuum, good sanitation, and proper tap placement, there is no difference in yield from above or below, Tadpoles placed above or below the lateral line. And this can really significantly increase how much conductive wood that we have to work with in the tapping zone and reduce the proportion of non-conductive wood. So if you have a lot of non-conductive wood in your trees, this can be a very good option for you if you have vacuum. This is not something you want to do on a gravity system. And then finally, if necessary, once you've taken those steps, if you're still hitting too much non-conductive wood, then you can focus on adjusting practices that do impact current year yields. So adjusting the tapping depth to being shallower, adjusting diameter to being narrower, and adjusting the number of taps. So in a real world situation, if you have something, you've got slow growth, you're hitting non-conductive wood relatively frequently, so more than 5 or 10% of the time, obviously the first thing you're going to want to think about is doing some thinning and promoting the growth of your crop trees. But first things first, increase the drop line length, tap below the lateral, probably reduce the number of taps per tree. So we've seen, especially when the smaller tree sizes and higher levels of vacuum, this is probably the least impactful of those tapping practices on yield. And then if you need to, consider adjusting to a shallower depth or a smaller diameter or both, and then see what happens over time. As the growth rates improve, you can potentially move to a deeper depth and better yields in that current year or a larger diameter. So it's something that needs to be adjusted over time as to adjust to the conditions of the trees that you have in your forest. So ultimately, you need to choose the tapping practices that balance the yield and sustainability for your trees. The tapping practices that are going to give you the maximum yields possible to result in a sustainable level of non-conductive wood for the growth rates and health, and also how much non-conductive wood is already there of the trees that you have. Because we need to optimize our current year yield, because they're ultimately going to be the thing determining our future yield. So that is a big, big treatise on tapping practices and how they impact yield near and long term. There are a couple of other tapping practices that are also worthy of mentioning, and obviously there's tons in this category too, but a couple that we have research on recently. Essentially, making good tadpoles is the most important thing that we do each year. It defines almost as much as Mother Nature does in terms of how much and how good the yields we're going to get from that tree. So proper tapping practices are essential. And this is a really interesting and critical point, because a lot of times we are putting tapping trees into the hands of people that might not have as much experience as us, people that might not have as much invested in our yields as we do, if we're the owner of our operation. So this is a really tricky and important point. So one thing that we've studied recently is overdriving of spouts. So, you know, this is kind of a simple tip, but if you're out there with a framing hammer tapping in your spouts, that's probably not a great idea. And this is in part because we have research, and this is based on some research started by Mike Recklin, who I know is here. Hi, Mike. Basically, we did some research following up on some research that Mike did that showed how big and significant the yield loss is from overdriving spouts into tadpoles. And we've all been there. It is super tempting to go just a little bit further and just make sure that it's tight. And that's fine, but it's important to understand that too far is going to hit you in the wallet. So basically what we saw was for spouts that were partially overdriven, so these were driven in basically, I think, 0.6 of an inch more than they should have been, those lost about 10% in yield. And that is likely from a combination both of blockage, basically not enough room for sap to move, but probably also some leakiness, not overt leakiness from the bark, but possibly some. We didn't, there was no real way to measure microleaks in that way that are that tiny. And then we had fully overdriven spouts, which went in 0.6 even further. So basically that was driven in 1¼ inches in a 1½ inch hole. So definitely not a lot of room for sap to move. And those spouts lost 42% of the sap relative to a correctly driven spout. So just not even making the clean hole, which is also another very, very important thing to do, but how well we drive in our spouts, how carefully we do, can have a significant impact on yield. All right, so moving on to our third big factor, check the time here, is sanitation. And sanitation of both the tadpole and the tubing system, but fundamentally it's about the tadpole. And this is one of my favorite pictures. And I'm sure after a year like the one we had last year, I'm sure you guys all saw a lot of this year. So we know that microbial contamination of the tadpole reduces yields. This is a figure from a study that we did quite a number of years ago now, following the yields from systems, from full mainline systems after they were newly installed. This purple line is a system that was cleaned only with water and air. So essentially no sanitation, just debris removal. And you can see that there is a fairly dramatic reduction in yield over time. Some of that is due to the loss of tightness of the system, but lots of it is also due to microbial contamination. And you can see, at least in this study where we're looking at replacement strategies, we can see that various replacement strategies help ameliorate and improve those reductions in yields due to microbes over time. We can see the same thing, this is over years, but we can see the same thing over the course of a season. This is a graph from Steve Childs at Cornell comparing the yields from new and old drop lines over the course of a single season. So you can see that the yields from trees with both types of drop lines start out fairly similarly, but once we get into the season, the yields from the older contaminated drop lines really dropped off relative to the new drop lines. So, and again, some of this is from loss of tightness, but lots of it is also due to microbial contamination. Essentially, microbial contamination hastens the process of tadpole drying and the cessation of sap flow. So the overall objective of any sanitation strategies is to reduce the microbial load at the tadpole and ultimately give us increased yield, potentially quality, and ultimately net profit. So none of this is really worth doing if it costs more to do than it does to implement, which is a big thing to think about because some of these things are not cheap. So there's two basic categories of sanitation strategies. One are replacement strategies. This is where we are placing new uncontaminated material near the tadpole to help reduce microbial levels in the tadpole and also reduces small leaks, so increases tightness. So you kind of get two bangs for your buck in a replacement strategy. And then we also have sanitizing, where we're actually using chemical sanitizers like peroxide or bleach that kill and reduce microbial populations to try and reduce the microbial levels that get into the tadpole. And these also have the added bonus or the added effect of sometimes I would say, removing some debris and having a kind of cleaning effect from just basically removing crud. So we, as well as Steve Childs at Cornell and other researchers, have looked at sanitation for a long time, and probably everyone that's here tonight has heard me or Tim or Steve talk about this over the years. But so I'll present only one figure tonight, yay. This is a combination or an aggregation of the results of dozens of studies, actually more than dozens, over the years, over a decade of looking at this. And it's showing the average percent yield improvement from various sanitation strategies. So you can see that and this is the percent above doing nothing. And so you can see that all of these sanitation strategies do something. This is replacing spouts annually. So we see about on average a 30% yield improvement for that, replacing spouts every year. We see much bigger improvements with bigger changes using a check valve spout. And check valve spout is going to prevent sap from backflowing into the tadpole and contaminating it with contaminated sap from the tubing system. So you can see about a 70% increase in yield from using a check valve. Obviously, using a new drop, an entirely new drop, including the T, gets you pretty big bang for your buck too, about 75% improvement. A well-sanitized, bleach sanitized drop line also can have a significant yield improvement. The trick there is that this requires a long contact time. And achieving a long contact time has its own special needs. And we've seen people develop ways to remove drop lines and bring them in and soak them and put them back. There are ways to do it in place. If you're very careful, you can get this, you can get a long contact time, but really it needs to be 30 minutes or so in a drop line that already has the sap removed in order for this to be that effective. But Bleach is cheap, so it is a pretty cost-effective strategy to do if you're doing it well, as long as you're factoring in that labor and helping, you know, the extra labor that it's going to cost to do that. And of course, with bleach, it needs to be rinsed or a significant amount of the first sap let go on the ground to prevent contamination. Peroxide in our studies didn't have a super great improvement. I'm not sure why. I don't have a good rhyme or reason. There were fewer studies with this one, but again, in 8 studies, we saw on average around a 20% sap yield improvement. Isopropyl alcohol also had significant improvement. It's a little less cost effective because it's much more expensive than a sanitizer like bleach, which is relatively inexpensive. And over here, these are the zap back spouts, which also resulted in a fairly good improvement in yield over time. Although these do need to be replaced relatively, they don't last forever. And they're generally not accepted in organic. Anyway, so when it comes to sanitation, the strategy that you choose is definitely not one size fits all. I know plenty of people that are very, very content to remove every drop line from their tubing system and bring it in and soak it in bleach and go for that for years and years and be very, very happy with the yields that they achieve from that. And I know other producers that would just not even consider it, even in the worst of circumstances. So ultimately, the sanitation strategy that's right for you is the one that's right for you. And so we have this spreadsheet where you can input the variables from your system. So your baseline yields, your labor costs, et cetera, and you can enter the characteristics of your operation to see which of these sanitation strategies may be the best net value for you. The lower the overall sap yield that you're getting to begin with, the less cost effective any of these strategies is going to be. So this really can vary quite a bit depending on your operation. So you can download this at mapleresearch.org and try it out. I highly suggest that you do that. It's pretty fun. And then now we can move on. We have a little time here left. We can move on to some other factors that are not about extracting the maximum amount from the tree, but factors that impact our overall operation yields. And one of them, and this many of you may be laughing like, well, duh, of course, but you would be surprised at how much this affects the bottom line of many, many operations, many well-run operations, producing syrup at the correct density. Not too high, which is basically kissing money goodbye and watching it roll out in barrels out of the sugar house, and also producing syrup that's too low of density, which can ferment and lose you even more money. So there are many, many ways that this producing syrup at the correct density can be achieved, or sort of things that need to be followed in order for that to be achieved. But the first one is to have your hydrometer tested annually and make sure you're using it correctly. My colleague again, Mark Islehart at UVM Extension, has a great video online about using hydrometers correctly. You can also attend one of the grading schools, which is a really, really good way to get practice and good, basically hands-on learning with that. But having it tested annually also really makes a difference. The ones that are state tested do go through a testing process each year, but I know from experience, I've had lots of those that are not testing accurately the following year. And that may have even happened during the first season, I'll never know. So it's really important to have it tested annually, and there are various ways to do that depending on where you live. And there are lots of other best practices. I know a lot of producers that don't measure the temperature when they are using their hydrometer. It's really, really important to do that. The hot test is at best an estimation. There is actually no calibration for the density of syrup and the hydrometer reading at temperatures above 180 degrees. It's unknown. So basically where that red line is a best guess. And it's been like that since the beginning of the industry. So it's really important to measure the temperature. And it's also really important to get it to recheck at room temperature where the hydrometer correction is actually known. You can recheck it with a hydrometer, or you can recheck it at room temperature with a refractometer. Either way, that's going to be the more accurate way to measure density. And lots of extra care when adjusting density. Anybody that's ever adjusted density knows that this is a really big pain. It's very difficult to get things to mix accurately. And there's lots of tools and tips for doing that. And the best place that you can look at the Candy and Confections Notebook from New York State, or also the new edition of the North American Maple Producers Manual, which is coming out, has some great tips and very well written passages about how to do this well. Another big factor is to produce syrup without off flavors or defects. And again, that sounds stupid, but we lose a lot of money. So we estimate, or it is estimated, that we produce on average as an industry about 10% of the crop each year is off flavored in some way. And that's probably an underestimate, because that's of the syrup that actually makes it to the buyers. This is not including the stuff that was so bad you wouldn't even take it to a buyer that would be likely to buy even the worst stuff. So 10% is probably a low amount. So lots of off flavors being made, lots of preventable off flavors being made. And this is a whole topic for a whole 17 presentations, but a couple of just basic things to do and to keep in mind with this are to refresh your off flavor and good flavor memory often. So getting one of these off flavor test kit or sample kits is a really great idea, especially for new people working in your sugar house, and for everyone to just remind yourself, what does Buddy taste like? How does it differ from metabolism? Things like that. Make sure you're tasting your syrup often, not just in the heat of the moment, but afterwards, after the season, and by more than one person. That's also a very good idea to do. And this is a very apt and timely slide after this year. I would be willing to bet when everything is in after this year is over and everything is in at the Packers, that this is the year that we will see the most sour and ropey syrup on record. Plenty of people I know were producing sour syrup and ropey syrup throughout the season this year because of just how things, how it rolled, how it transpired. So there are lots more practices to prevent sour and ropey syrup than what I have listed here, but some of the basic ones are to make sure that you're boiling 15 minutes at least after the last drop of fresh sap has come in, whether you need to do that by raising the depth or adding some permeate. You need to do that to make sure that you're killing most of the bacteria that cause ropey. You also need to drain all the site levels and the float boxes each night and clean them to make sure that there's no ropey bacteria going in there, or sour, either one, because those places basically are where sap sits and never really heats. And of course, if you're stopped more than 3 days, boiling the sweet for 15 minutes and cleaning and sanitizing all the feed pipes, all the releasers, and really when the temperature is warmer, like really warm, I probably would say more frequently than 3 days. And again, this is just the beginning. I think we'll have a whole presentation on just sour and ropey upcoming, so stay tuned. But for now, these are the very, very, very basics. And then more practices to produce syrup without off flavors or defects have to do with best practices for foam and niter management. So everything that we do here is going to reduce our chances of off flavors from too much defoamer, rancid defoamer, niter, scorch, burn, and chemical off flavors. So this begins with controlling niter, which ultimately really begins with controlling the heat. So the less heat we have in the evaporator, the less hard the niter is going to be adhered to our pans, the easier it's going to be to remove. So that is the beginning of managing our niter well. And so this also includes being really rigorous about how often we're reversing flow or changing pans really frequently in order to keep that niter soft and easier to remove. At the end of the day, we can also help ourselves by draining the pans and boiling with permeate and soaking for a while, or if you're lucky enough to have an automatic pan washer doing this. All of those things are going to reduce how hard the niter is adhered to the pans, which is going to reduce the chances of niter off flavor and scorch and burn, but it will also reduce our need to clean with acid. And not only is that good, because of course now we have new regulations coming down the pipe that are going to make cleaning with acid even less desirable than it ever was, but also because when we're cleaning, especially if we have really nitery pans that we're cleaning with acid, we need to be excruciatingly careful to remove all of the niter when we do that, including from the sides of the pans. And that's because acid residues can get trapped in any remaining niter. And so it can then lead to that acid residue contaminating the syrup. And so, you know, while we often hear, and it's true that some niter off flavor results in a, you know, kind of a burning sensation on your tongue. Well, you can also get that sort of from niter, but because niter can actually beget a chemical residue off flavor and a chemical contamination, which will also burn your tongue. So these are all related to one another. And of course, niter management, niter is also going to lead to more foam. And so taking care of niter is also going to help reduce the amount of foam we're generating, help us reduce the amount of defoamer that we're using. Also managing heat is going to help us there. Defoamer and helping prevent defoamer off flavors. There are a lot of different issues here, everything from taking care of the defoamer that we're using to make sure that it isn't rancid. So, you know, especially with organic oils, those do not stand up to heat. They need to be replaced every day. How we dispense it is really going to affect how much we use. That's a subject for another presentation. But we really need to be making sure we're using as little as possible, especially close to the syrup draw. And of course, taking care of sap quality is also going to make sure, you know, the worse our sap is, the more foam that we're going to have. So that is also going to help us use less defoamer. And then other losses that we can prevent, they're all over the place. We can help minimize our losses from the RO and other sources with our best practices. So when is the last time you checked the conductivity of your permeate to see if you were losing sugar? So we can have a significant loss of permeate in our RO at levels where our handheld refractometers aren't able to detect sugar. They're simply not sensitive enough. So by measuring the conductivity, we can get an idea of the likelihood that those membranes are passing sugar at levels way lower than our refractometer can detect. So if you're measuring your permeate and you've got conductivity greater than 10 microsiemens, you probably have an issue with passing sugar and need to take steps to address that. And other things are making sure, and these are simple things that many of you probably already do, but plenty of people in the heat of the season these things can kind of get glossed over. Making sure that the sugar rinse from the RO is totally complete. How we're managing our sweet from filtering. Are we retrieving all of that? Are we getting it back into production? And even things as simple as foam management. You know, are we managing foam well enough by controlling our heat to prevent losing 5 or 10% of our syrup on the floor with major foam overflows? These are just all things. They're little things, but they add up. And so I think it's a good place to stop. I have more, but I think I'll stop there and see what you guys are asking. I just wanted to put in a plug for mapleresearch.org. This is a comprehensive database that includes all the research that I talked about tonight that is run by the North American Maple Syrup Council in partner with UVM Proctor Center. And yeah, we'll skip red maple for the moment and just go to questions.
So there's a good bunch of 7 or 8 questions in the chat, Abby, if you want to read them from there, or I can read them to you, and then we can open it up to other folks, and then we can get to the last 3 hours of your talk.
Sure. I mean, you guys are, everybody just go grab another beer, just relax. Yeah, I'll read the questions. So the first one is from Matt, and it says, has any research been done concerning number of taps per lateral and sat per tap effect on 316 vacuum tubing under mechanical vacuum? And I want to say, Matt, probably yes. Tim Wilmot did some of this a while back. I can't remember off the top of my head exactly what he found, but if you look in mapleresearch.org, it should be published there. As far as I remember, that one was published in the Maple News, but you should be able to find it pretty quickly there. Sorry. Another question about 3/16 from Rich. We are using gravity vacuum on 3/16 line. Does the rule of thumbs on taps for lateral apply to us? And the answer is no. Generally, you can have a large number of taps per lateral in a 3/16 system if it's an advantage in that system. And I would recommend that you go to the same resource as I just recommended, Matt, to look at that for 3/16. A question from Richard, is there an optimal location of the saddle entry point to the main line? Does it matter if you enter at 12 o'clock, 9 o'clock, or 6 o'clock? That is a really good question. And the true answer to that is, I have no idea, Richard, none. I know that we haven't studied it. So I'm gonna have to say, I don't know. And if anyone wants to chime in, if they have noticed something about that, feel free to chime in, but I don't have an answer. I definitely know I don't have any data on that. Next question is from Chris. If I am not using vacuum, just tapping into a bucket old school, should I expect consistently higher yields out of large trees by using 2 5/16 taps rather than just 1 per tree? And generally, Chris, in a gravity situation in buckets, if you've got a big tree large enough to accommodate 2 taps, so definitely above 18 inches, preferably a little bigger, then yes, you should, in that situation, a gravity bucket situation, you should be expecting higher yields by using the 2 5/16 inch taps per tree. But again, making sure, of course, that that tree can support it. You know, if you've got enough conductive wood to put those taps in and get clean wood, then you're good to go. But if you've got one that's kind of clean and one that's kind of into some brown wood, then you're probably much better off with just a single tap. All right, next question is from my good friend Keith Heasley from West Virginia. What was the size of the trees used in the 1 versus 2 tap comparison research? And Keith, they were relatively small. I'm going to try and go back up there without giving you all seizures. Let's see where we are here. Way back, sorry about that. So you can see here that these are the 2 tap trees here. These are the 1 taps. So the range was between 13 inches and 20 inches. So in general, pretty much on the small size for having 2 taps for trees. And, you know, as a researcher yourself, you know that sometimes this is one of those things that happens. You just don't have the perfect trees for the research that you want to do. So we are actually redoing that study with larger trees to make sure that we really get an idea of, you know, how much of that is of the effect that we saw, where we saw no difference in yield from 1 tap to 2 tap, how much of that was influenced by some of the smaller tree size. So that's a to be continued. And from Matt Fisher, has yield from 2 taps per tree versus 1 tap per tree been researched on sugar maple or black maple? And the answer is yes, it has been for sugar maple. We basically saw that research was done by Tim Wilmot several years ago, and basically saw the same thing that we saw in red maple trees, at least to an extent. And we did not expect the red maple trees to behave differently than the sugar maples, and we still don't think they did. But just in case, we're redoing the study on sugar maples only, so I'll have even more updated data on that upcoming in the future. And question from Stu. It is my understanding that tapping below the lateral is not an option on gravity. And Stu, you are definitely right about that. Tapping below the lateral is a really bad idea on gravity. I do not recommend it. If you want to try and give yourself a headache, you can try, but it will not work on gravity, at least not very well. And then also from Stu, Maple News carried an editorial column recommending cleaning 3/16 line with swimming pool bleach, calcium chloride, and leaving in lines till fall before hot water rinsing. Do you concur? Well, yes, we actually have it. Unfortunately, that swimming pool cleaner actually also is this Zapit calcium chloride bleach. I'm sorry, not calcium chloride, calcium hypochlorite bleach. That is also a potable water sanitizer. So even though that particular product can be used for swimming pools, it is also food grade. So that part is okay. And we do often recommend using calcium hypochlorite because it does seem to be less attractive to chloride, less attractive to squirrels than sodium hypochlorite, regular sodium hypochlorite bleach. So in that regard, I can't not recommend that. That's actually totally kosher to do. Leaving in fall before hot water rinsing, you know, long contact time is always a good idea. I don't know about personally whether I'd want to leave it in the lines all summer long, nor do I know whether hot water rinsing is necessary. Again, these are things that I don't have research on. Art Kruger, who wrote that article, definitely has a lot of experience doing that. So, you know, he has a lot to add to that conversation. I have personally never left bleach in that long or hot water rinse, so I don't have a good answer for that. And let me see what the next question is here. The question about, could I give a little more information on vacuum increasing freezing at a higher temperature? Is there a chart or formula for this? Well, John, I'm sure there's a chart or formula for that I do not have. So I can't say anything more than Googling it. I can't off the top of my head remember. I want to say it's, no, I'm not going to say because I won't remember it correctly. But basically at 28 inches of vacuum, the freezing point is about 39 degrees Fahrenheit. So that's the one that sticks in my head. I don't know the formula or the conversion is not in my head. So basically the higher you go, the more the freezing point will increase. And this does get, make everything a little bit funny. And I see a couple of direct questions from Jim, and Jim, maybe you can tell me whether you want me to answer them publicly or not, just to make sure. And I would welcome if anybody wants to open up their mic and ask a question directly. I would welcome that too, Winton, if that's okay.
Of course. Anyone would like to unmute yourself and ask other questions or type them into the chat? No one's video is on, so they may all be eating or.
I hope you're all relaxing on your couch. That's what I would be doing if I wasn't up here. Okay, I'm gonna address the question from Jim. Jim wanted to know whether we're studying vacuum modulation, basically modulating the level of vacuum to kind of adjust for some of that hankiness with the freezing temperatures and stop freezing the lines. And the answer, Jim, is currently no, we are not studying this. In part, how do I want to say that? I'm just going to leave it there for now. But right now, the short answer to your question is right now, we are not actively studying it. But if you want to give me a call sometime or shoot me an email, we can get into a lengthy, super geeky discussion about it. Any other questions?
Kevin posted one more in the chat.
Okay. Kevin asked, I did have faint flavor in my syrup this year, not off flavor, but it seemed muted. What can cause that? This is some of my favorite questions, like being a detective. Kevin, I might ask you to unmute so you can tell me a little bit more about it, but some of that simply could be, well, I'm not even going to say that. If you'll unmute and explain a little bit more of what you experienced.
Sure. My aunt went to the taste testing school a while ago, so I had her test our syrup. It's the second year I've made it, and she said it tasted fine. It just tasted kind of muted, like almost like it was diluted, kind of. But the bricks and everything was correct.
And that's muted relative to what you would typically produce, what she's used to you producing?
She said just kind of in general. It's the first time I've made more than, like a couple cups. So it's hard to judge on what I've made in the past, but.
Okay, well, it may just be that it was a nice, delicate flavored maple syrup, and maybe she was more accustomed to or comparing it to something with a little more extensive caramelization and extensive flavor development. I would go there before I started, imagining what could be wrong with your syrup. It might have just been a nice light syrup with not a whole lot of flavor. What kind of evaporator are you using? What kind of practices?
Just homemade on a like camp grill in a pan that you'd usually use like to heat stuff up at a buffet. Very low tech.
Yeah, so you should have, terrific flavor using that, as long as you're not like injecting air into it at the same time or something.
No.
I would expect that is probably a really nice maple syrup that you made.
Okay. Yay.
So you can always my suggestion also in that case, if that is where the good best practice of having more than one person taste your syrup, because even though your aunt's been to the grading school, she's one person, and every one of us tastes flavor completely differently. Like, we can agree on some objective things, but a lot of our perception is so individual. So I would love to hear what other people thought about that syrup too.
Okay, cool. Thank you.
You're welcome. I have another question from Richard, that is, if you mix a little amount of ropey syrup with good syrup, will it cause the good syrup to get ropey? And the answer is probably. It kind of depends, but you can, it's not safe to do, and it also doesn't really fix the problem. There are ways to work with ropey, and that mixed blending it is not the best one, I would say. I'm going to get myself into trouble if I keep rattling on and just end that one right there.
That sounds like a teaser for the project you said is going to be coming out soon.
Yeah, so for those of you here, I just submitted a proposal to do an all flavor research and education project. So all about preventing preventable off flavors and promoting good flavors. So fingers crossed, it just went in yesterday. And so hopefully it'll get funded and you guys will hear me up here yapping about flavor for 3 more years.
All right, well, why don't we wrap it up? Thank you, Abby, for putting in so much of your time.
Well, thank you for having me. If anybody is dying to hear about red maple, you can feel free to stick around and I'll go over those slides, but I think everybody's probably ready for bed at this point, I would imagine, and we can just do a separate seminar later.
We've started losing some folks, so but not everyone's bailing. If you're eager to keep going, we could talk about red maple for a little bit.
Well, I can do it in 3 seconds.
Whoa.
And I'm contractually obligated to do it, so my agent makes me do it. But I just wanted to put in a quick nod for red maple. And basically we have a study ongoing looking at the actual yields from red maples compared to sugar maples to see whether they are indeed the same, which we expect they are. And this year notwithstanding, where are we here? Our results from 2020, which was an actual normal year, showed fairly solidly that over the season, now although the red maples were producing sap with less sugar content, they were producing much more of it. So at the end of the year, our red maples and our sugar maples of the same size had exactly the same yield. We redid the study in 2021 to have a better average, but 2021 was such a terrible year that we aren't able to use the data from just about anything, which is pretty sad. So we'll repeat it the following year. But really consistent relationships between red maple and sugar maple as we go up in size. And so in terms of practices to maximize yield, I know there are some of people in this room, plenty of people in the maple world that feel a little bit twitchy about tapping red maples, even when they have them in the bush. So one really good way to increase your yield is to add those red maples in. And we have some pretty solid data to make us not shy about doing that, not reserved about doing that. And obviously the other big question that we have with red maples is, is it going to do something to flavor, or is it going to make buddy earlier, things like that. So next year I'll be doing a side-by-side syrup production experiment with all red maple sap and all sugar maple sap from the same stand, and compare the flavor of the syrup we'll make with those to make sure that, again, flavor isn't a reason not to tap red maples. So I just wanted to mention that, and as a sort of maybe it's not an obvious direct line to increasing yields, but in my mind it is. For many producers, adding those red maples in is really going to be a way to increase yields. And that, I think I can just leave it at that and let you all go to bed.
All right then. Thank you again, Abby. Thank you, everybody. I will send an email out when this is up on mapleresearch.org, so you can all share it with your friends. And with that, we'll sign off and keep an eye out for emails about future presentations. Thanks again.
Thanks for coming, everyone. I appreciate it. Bye-bye.